Go. Product rule, quotient rule. So when we talked about limits, and when you talked about a lot of other math things, we find ourselves repeating the same thing over and over again. Like, for instance, the limit of a sum is the sum of the limits. The derivative of a sum is the sum of the derivatives. That breaks down when you get to products and quotients for derivatives. In other words, the derivative of a product is not the product of the derivatives. You got to have a whole new rule for that. We're going to talk about that today. We're going to talk about the quotient rule. Then we're going to stop. Then we'll come back to more 2, 3, and we'll talk about trigonometric function. Well, here, let's do this. Let's start with that guy first. Then we'll go through the objectives of what we're going to cover today, and then we'll get that done and take care of all of our other business. Let's make sure at this stage you can take the derivative of some simple terms. Absolutely. Sorry. There's a mess. Sorry about that. Tim, what do you got?
20x to the third. And then it'd be plus 18x to the negative 7. And then would it be 12 is a constant? Would that be 0? And then it's x to the 1/2, so plus 1/2 x to the negative 1/2.
Close. You don't take the product, you just treat that as a constant.
So
Nope. Jocelyn?
Oh, I was going to say something.
Bill?
I got 6 times x to the negative 1/2.
So you had the derivative of that correct, but remember it's a constant, so you just take the derivative and then multiply by the number when you're done. Okay. Last question for you, Tim. If you put yourself in my position and you've done this problem a number of times now, where do you think the most common mistake that people make in this problem is?
most common mistake. What I just did again.
That's number 2.
Okay.
The negative 6.
So what's a mistake that they make?
They add 1.
Yeah. So negative. Anybody want to cop to that? I don't think so. Okay. But yeah, that's the single most common mistake is people take negative 6 minus 1 to get negative, or they take negative 6 plus 1 to get negative 5 instead of the negative 6. Beautiful. We're all on the same page. So, like I was saying, we're going to talk about the product rule today, how to do the derivative of a product. Talk about the quotient rule, how to do the derivative of a quotient. And then later on in the week, we'll get to the other 4 trig functions. We've done sine and cosine. We got to do secant, cosecant, tangent, cotangent. And then we'll talk about higher order derivatives. These are pretty easy. If you can take the derivative of f to get f prime, then you can just take the derivative of f prime to get f double prime, etc., etc., etc. That goes on for a while, but eventually you reach a point where it stagnates. So for instance, if I take a basic parabola, like x squared led, and I take the derivative of that parabola, what do I get?
You get 2x.
Good, which is graphically, what's that look like?
A line.
A line with a slope of 2. Beautiful. Then I take the derivative of that line and I get?
Negative 2x.
Nope.
Oh, geez. 2x. Right? 2.
2.
Oh, jeez. I'm blanking out.
It's okay. you're under pressure here,
Yeah.
which looks like what if you graph it?
A constant horizontal line.
Horizontal line. So then I take the derivative of that.
That would be negative zero.
Zero.
Zero, yeah.
Another horizontal line, the x-axis. Now what happens if I take the derivative of that?
Horizontal line axis.
Yeah, so now it begins to repeat itself. So you can imagine then if we start with something that's like an 8th degree equation, as we continue to take the derivative of that polynomial, the degree drops, but eventually we'll get down to that whole idea of 0. That's great if you have a nice pretty polynomial, but what if it's not a nice pretty polynomial? So we'll talk about that for the higher order stuff. And then, just for today, be nice to some freshmen. Okay, they're having a rough week, and it's only Monday. At least my freshmen are. Okay, let's start with that. You should have enough knowledge to find the derivative of that function h. So go ahead and do that. Sit in the corner next to Vlad. He promises not to bite anyone anymore. You got that under control now, right? You get your shots over the weekend?
Sure.
Okay, he's safe then.
I'm still a vampire then.
I understand. Oh, I get it, Vlad. Like Vlad the Impaler. Yeah, that's good. That's not where I was going with it, but that's cool.
We'll see.
Uh-huh. Taylor, tell me what you're working on right now. How you approaching this?
Well, I wasn't sure if I could multiply it out or not first.
Good.
Yes?
Yeah.
The answer is yes.
Because how else would you do it?
Well, you can't take the derivative of each separate one and then put them together.
Correct. So that's the first, let's talk about mistakes again. The first common mistake that people make when doing this is they forget the product rule, which we haven't talked about yet, and they'll find h prime by doing the derivative of the first times the derivative of the second, multiplying that puppy out. And again, that's wrong. That doesn't work. So then you're multiplying that thing out, getting a big polynomial. It's not that big, but it's a polynomial. Do you have that yet?
15x minus, or no, wait, plus 12x minus 10x squared minus 8x cubed.
This should be 12x squared?
Yeah. Oh, yeah, sorry.
Okay, so then we're getting 15x plus 2x squared minus 8x cubed. Are we all in agreement here? Yeah, okay, so multiply it out, then take the derivative. Do we need to bother doing the derivative here, or are we good? Give me some feedback, yes or no? Yes, take the derivative.
No. Not take.
No, do not take the derivative, because yes, you're good.
Yes. I'm good.
Is he speaking for everyone?
Yes.
Correct that he's speaking for everyone, great. Okay. However, as the functions get more complicated, the last thing you want to do is multiply out these big scary things. And so therefore we're going to, oh, this is what we just did. Okay, so then get that there. Is that what we had? Yeah, okay, good. But we can then switch to the product rule. Now there's a lot going on here, so before you start writing like mad people, let's talk about a couple of different things. First of all, in the calculus speak up here, it's important to notice that the functions have to be differentiable. You have to be able to take the derivative of f and the derivative of g before you can apply this. Second of all, you need to notice that they actually use the word moreover.
Wow. That's it.
Thought that was pretty impressive. Yeah. I mean, I don't know if you've ever used the word moreover, but they did.
I used to try and sound fancy, but that's it.
If you can do moreover, hence, and therefore in the same sentence, you're golden. Okay. The rest of this is all straightforward, and in fact, I put it in a little bit better English for you. This is the actual formula, so we're taking the derivative of the product of two functions, which are differentiable. you get f of x times g prime of x plus g of x times f prime of x. First times derivative of the second plus the second times the derivative of the first. And we'll go back and do that same example using the product rule just so you can see what it looks like. This is the easier of the two. The quotient rule is a little nasty. Okay, we ready? Here we go. Excuse me. Go back here. H prime. Be careful with your notation. If you're taking the original function and you're just algebraically manipulating it, then list it as such. In other words, if I was going to multiply this out, I would still write h of x is, and then do all the calculations. Now that I'm starting to take the derivative, it should be labeled as h prime of x. College Board gets really weird about that kind of labeling stuff. Okay, so the first times the derivative of the second plus the second times the derivative of the first. In this particular example, you would have a valid argument if you were to say, I thought it was easier if we just multiplied it out. That is true. Okay. You still have to go through all this work here. Equals 12x minus 8x squared plus 15, that's 12 minus 20 is negative 8x minus 16x squared. Did I do that right?
Yeah.
Okay, good. Which means negative 24x squared plus 4x plus 15. Please tell me that's the same answer. Okay, good. When you get into the problems on the homework, there's going to be two components to those homework problems. One is going to be getting to this stage. The second part is going to be getting to that stage. And you'll see eventually that this is the more difficult part of it. Simplifying the answers are more difficult than actually just applying the theorems. I don't know why, but there's a whole bunch of algebraic tricks that we're going to go over that you're going to get more comfortable with. Can I erase this? Yeah. Good. Now we'll do the quotient rule. Product rule, not that, quotient rule. Okay, more stuff going on there. Again, f and g have to be differentiable. Nothing changes there. However, g of x cannot be equal to 0 because then we have a function over 0 which doesn't work. Also notice they used moreover again. 2 theorems, 2 moreovers, pretty impressive. And then that big scary thing. In your notes, however, I neglected to include this, put brackets around that last term. Those brackets are very important. So when we talk about common mistakes in the quotient rule, that's the biggest mistake people make, is those parentheses, because it means that they're not going to distribute that minus sign. Eventually, not yet, but eventually we'll get to a point where you pretty much don't need to do the quotient rule. because we can turn quotient rule problems into product rule problems. I'll show you what that looks like in the example. But at this stage, we don't have enough information. There's one other rule that we're gonna get to eventually that'll help us get there, but right now we can't. Most people do not like the quotient rule because it's so big and scary. All right, ready? Yeah. Good, okay. Oh yeah, there it is in English, which is what this says. I'm gonna skip this for a second and go right to the example, and then I'll talk my way through it so you can hear the thought process that I'm using to solve it. Hopefully you find that helpful. Getting back real quick to what I was talking about, eventually we'll be able to do this and write it this way and do it as a product rule, but we don't know how to do that one yet. That comes later. So now this one we have to do as a quotient rule. Okay, so y prime is equal to, I start with the big gazinta bar, take the denominator, put it on the bottom and square it. And don't multiply it out. Never multiply out denominators. You're gonna see some instances where it's tempting. That x is just gonna wanna scream in as a distributive property to the other one. No, just leave it like that. Then take that denominator and write it up on top. Okay, so square it on the bottom, write it up on top, times the derivative of the numerator, minus the big honkin' brackets, which are so important, the numerator times the derivative of the denominator. Close your brackets. Okay. Same thing with the product rule. That's step one. Step two, the more difficult step, in my opinion, is the simplifying. Don't multiply out denominators, but you must simplify numerators. 5x squared plus 5. Minus 10x squared plus 4x. Is that right? Yeah. All over x squared plus 1 quantity squared. Gives us negative 5x squared plus 4x plus 5 all over x squared plus 1 quantity squared. The last thing we want to check is that numerator. Can that numerator be simplified at all? In other words, does it factor, which would give me an opportunity to cancel? It doesn't, so we're good to go there. Denominator squared on the bottom, bring the denominator up to the top, times the derivative of the numerator, minus the numerator times the derivative of the denominator. Simplify numerators, leave denominators alone. Nick has a question, go.
Are we gonna like be able to use our calculators and use the quadratic formula to like figure out the top part?
Sometimes yes, sometimes no. What I've seen in my experience is anytime you get to something like this where the numerator would need to be factored, it's pretty obvious that it can be factored. Very seldomly will you be given a problem where you gotta do like quadratic formula and get some decimal gunk in there. Not gonna happen. It'll be something that breaks down nicely that would cancel with something on the bottom. And that would be the only reason you'd factor it, is to get some canceling. Okay, questions, concerns, problems? Now it's just application of those things over and over again. And every one of these problems is gonna introduce a different trick that you may not have seen. So we're gonna spend quite a bit of time going over homework to show you some of those tricks that pop up. I have an example of one of those tricks when we're going over the test also. Things like factoring out a -1. Can I erase?